Consider the polynomial x squared minus 3x minus 10. In this example, we have to find zeros and verify the relationship between zeros and coefficients of this polynomial. It means we have to do two things. First, we have to find its zeros, and second, we have to verify that our answer is correct. To find the zeros, let us factorize it first. This is not a perfect square, and so we use splitting the middle term technique. The coefficient of the middle term is minus 3. We have to split it into two numbers such that their product is minus 10. This minus 10 is the product of the coefficient of x squared and the constant term. The two numbers will be 2 and minus 5. Their sum is minus 3 and the product is minus 10. So we write this polynomial as x squared plus 2 minus 5 times x minus 10. We open the brackets and write the polynomial as x squared plus 2x minus 5x minus 10. Then by using the grouping technique, we make these two groups and write it as x multiplied by x plus 2 minus 5 multiplied by x plus 2. We took the common factor from each group out. And in this entire expression, the binomial x plus 2 is common to both terms. So we write it as x plus 2 multiplied by x minus 5. To find the zeros of the polynomial, this has to be 0. It means the value of the polynomial has to be 0. And for this entire thing to be 0, one of these has to be 0. So either x plus 2 equals 0 or x minus 5 equals 0. Transposing 2 and minus 5 to the other side, we get x equal to minus 2 or x equals to 5. So the zeros are 5 and minus 2. If we put either of these two values in place of x, we will get the value of the polynomial as 0. The zeros are also sometimes referred to as the root of the polynomial. We completed our first step. We found the zeros. Now we need to verify if they are correct. Let's zoom out a bit. First, let us calculate the sum of zeros. It is 5 plus minus 2, which equals 3. The sum should equal minus b by a. b is minus 3 and a is 1. So it equals minus of minus 3 by 1, and this ratio equals 3. But wait, we're still not done. We need to verify the product of zeros too. The product of zeros is 5 multiplied by minus 2, and that is minus 10. Now we check if c by a also equals the same value. c is minus 10 and a is 1. So it equals minus 10 by 1, and that equals minus 10. Since the product also matches, the zeros we found are correct. So our answer is verified. Let's quickly skim through what we did. First, we factorized the polynomial to find its zeros, and then after we found the zeros, we verified its sum and product, which proved that our answer is correct.